let's talk about percent. So the definition of like what a percent or percentage is literally that it's just a fraction out of 100. So for example, 5% is the same as the fraction 5 over 100. Okay, so this like basically what this means is like, if you were to poll 100 people, then if you were to say 20% of these 100 people, to say 20% of this like 100 people like the color blue, then that would mean 20 out of those 100 people like that color. And of course the scale, so if you had like 200 people, then 20% of 200 is like, well, you convert that like fraction like 20 out of 100 times 200, so you would get 40 people there if you were to sort of think of it in terms of like solving that proportion. Yep, twice as many. Okay. Converting between fractions and percentages. So because a percent is just a fraction, it makes sense to be able to convert between fractions and percentages. So 25% is just 25 out of 100. Of course, that's not as helpful as having this in simplest terms, which would be like 1/4. So converting 25% to a fraction, it's more useful to convert it to simplest terms, generally speaking. You won't always be able to do that. Like 89% is just 89 out of 100, and I don't think there are any common factors there, so we'll just kind of leave it at that. 10%, this is 10 out of 100, but of course you could simplify that to 1/10. 50%, that's 50 out of 100. I'll just go right ahead and say that's equal to a half. 60% is 60 out of 100. You could cancel the tens, so this is the same as 6 over 10. And then you could cancel out like a 2 from the top and the bottom to get just 3 over 5. So 60% is 3/5. What would 100% be? This would be like 100 over 100, which is literally just equal to 1. So the number 1 is technically a fraction. Like 1 over 1 is just a fraction. Same as like if you were to do 0%, that's just 0, or 0 out of 100. They're all saying the same thing. Let's go backwards. Convert the following fractions to a this says decimal, but I meant to say percent here. Whatever, we'll just roll with it. Okay, 1/2. Let's convert this to a percent. So 1/2. All right, converting fractions to percents is like a little bit harder in my opinion. So you could always just kind of use a calculator and just like sort of convert to a decimal and then convert to a percent. Like converting a fraction to a decimal, if like I were to convert like 12 over 15 to a decimal, I could literally just use a calculator and divide 12 divided by 15 and see like what does my calculator tell me that that's equal to, and it would tell me that this is equal to like 0.8, I believe, right? Because 12 over 15, this is the same as like 4 over 5. If I were to cancel out a factor of 4 from factor out a factor of 3 from the top and the bottom, it's like 4 times 3 over 5 times 3, so we're canceling out a factor of 3. So this is like 0.8, which then if you convert it to a percentage, converting a decimal to a percentage is really easy because you just have to multiply by like 100 over 100. So this is like 80 over 100. But you could actually just like skip this middle step right here of like converting to a decimal first. And then you could just think of, all right, well, 1/2. If I wanted to convert 1/2 to a percent, I really want to just convert this to something with a denominator of 100. So what do I have to do to a half to convert it to a fraction out of 100? Well, my denominator is 2 right now, and if I want my denominator to be 100, I want to multiply that by that denominator by 50. So I should do that to my numerator as well, in order to keep this as an equivalent fraction. So multiply my denominator by 50, multiply my numerator by 50, and I'll get 50 over 100. Can do this similar thing to 3/4. I want my denominator to be out of 100. Oh, by the way, I forgot to write this as a percentage, but this is just 50%. Anyway, 3/4, want this to be out of a fraction out of 100. So I'm multiplying my denominator by 25 now. So I multiply my numerator by 25 as well. So 25 times 3 is equal to 75. So this is 75%. All right. 3 out of 20. I want to multiply my denominator by 5 to get that to be out of 100. So multiplying my numerator by 5 gives me 15 out of 100. So this would be 15%. I think that like seeing fractions out of like 20 and converting those to a percentage, like anything where like if your denominator is just like a bunch of like powers of 2s and 5s, like you can just kind of multiply by something to convert it to a fraction out of 100 in this same sort of way. And like if our denominator is 5, I can just multiply my denominator by 20 and then multiply my numerator by 20. 3 times 20 is 60. And then I get a fraction out of 100, so that's a percent. All right, well, what about something like 2/9 where you like really can't do this? So here you actually have to do like, well, what is 2 divided by 9 in your calculator? And if I do that, that's going to give me, as a decimal, 0.2 repeating. So 2, 2, 2, 2, 2. So this is like 0.2 repeating, which is the same as, well, let me actually just write it like this. Now, if I wanted to write this as a fraction out of 100, what I can do is multiply. So think of this as a fraction out of 1, so as is right now, and then just multiply my numerator and denominator both by 100. So this is like 100 times that over 100 times 1. And so multiplying my numerator by 100 just moves the decimal right 2 places, and I get 22.2 repeating over 100. And so this is really just 22.2 repeating percent. Okay. Yeah, notice how like this method was like way more convoluted than just converting this to a fraction out of 100. So, but like this is, let's see, this is like more computationally, you do the same thing every time. And so of course, like people tend to like things where you just have to do the same thing every time. But this is like more flexible, but more useful in other situations where like you don't necessarily have a calculator in front of you. Builds number sense as well. All right, percents to decimals. If we wanted to convert a percentage to a decimal, did I skip a slide? No, we're good. Okay. Yeah, so we did fractions to percents and percents to fractions. Now let's introduce decimals into the equation. So if I wanted to convert a percent to a decimal, this is pretty straightforward because this is just like 25 out of 100. So converting that to a decimal, I just literally divide 25 by 100, which just has the effect of moving the decimal over by 2 places. 89% would be 0.89. 10% is 0.10, but I put this example in just because it's like good to kind of remember, like you don't need to put the 0 here. You could literally just say like 0.1. That's perfectly fine. 50% in a similar way, you could write 0.50, or you could just write 0.5 because it's really just like a half. 0% is just 0. 100% is just 1. Something that kind of messes people up a lot is when we start introducing things like 2% or 0.5% or 0.07%. These tend to be harder for people for whatever reason, but you do them with like exactly the same process of you just move the decimal to the left 2 places, right? For 10%, the decimal's over here, move that decimal to the left 2 places, and it's just going to be right in front of the 1, right? So it's 0.10, and then you could just chop off that 0 if you so please, because the 0 is to the right of this 1, right? With 2%, you have to move the decimal left 2 places, and if you do that, then you get 0.02. With 0.5%, this would be, again, you go left 2 places, and if you go left 2 places, there's going to be 2 zeros after the decimal, so 0.005. With 0.07, if I move the decimal left 2 places, there's now going to be 3 zeros, so it's going to be 0.0007. So these examples tend to like mess people up a little bit more, but it really is the same process of like just move the decimal left 2 places, and as long as you just kind of like sit and think about that and then don't just like kind of instinctively just guess, you should be fine. Okay, and then decimals to percentages. 0.29. So it's easy to convert a decimal to a percentage usually, just because you can do the opposite of what we were just doing, where we just move the decimal right 2 places, and then it's now a fraction out of 100. So 0.29, reversing the same process that we talked about in the previous slide, is just 29 out of 100. 0.82 would be 82 out of 100. 0.1 would be like moving it right 2 places. This is really 0.10 out of 100. It's like 10 out of 100, which of course you could simplify. So a lot of times when you convert this to I'm converting to fractions and forgetting to convert to a percentage. So like this would be 29%, this is 82%, this is 10%. And so it's even simpler than what I was like about to say. What I was about to say is like, oh, well, if you're just converting to a fraction, then like you might have to put it in simplest terms, but you don't even have to put it in simplest terms here. You just move the decimal over, and then that's your percent, right? 0.5, convert that. You move the decimal right 2 places. That would be like 50 over 100, and now that's immediately, you could just say that's 50%. 0.33. For some reason, people mess this up all the time. They will say like, oh, that's like equal to a third. 0.33 and a third are not the same. Just do the same thing of just multiply by 100 over 100. Move the decimal right 2 places. This is 33 out of 100 or 33%. This is not the same as 1/3. These are different numbers. 1/3 is 33.3 repeating percent. 33% is a different number than this over here, right? If you think that these are the same, just don't get into rocket science or something, I would say. Yeah, they are subtly different. They're very close. And if you're approximating stuff, then like it's good to use numbers flexibly. Like there is a time and place for this, but just know that they're not always the same. All right. Anyway, moving on. Okay. So when we're solving problems using percentages, there tends to be like 2 main approaches we could take. The first approach that we could take is often referred to as the proportion method, and the other method that we often take is called the I'm just gonna skip ahead. It's called the percent equation. I'll tell you what this is in a second. No one ever calls it that, but we're just to emphasize that they are like 2 different methods. We'll call these something just for today, just so that you can kind of highlight the differences between the methods. The proportion method kind of makes sense. So let's suppose that 25% of people surveyed in a town sleep with their socks on. Just a stupid survey, right? Let's now assume that 180 people were polled, and I want to know how many of them, based off of this information, can we say how many of them slept with their socks on? All right. And then like a part B is going to be like sort of the reverse. Instead of knowing how many people were polled, we're going to know how many people sleep with their socks on, and then ask how many people were polled. So let's do the first one first. So 25% of people sleep with their socks on, and out of 180, some number of them sleep with their socks on. So we can say that 25% is equal to, let's say like n for the number of people that sleep with their socks on, over 180. And let's actually go ahead, instead of saying 25%, let's just call this what it is, like 25 out of 100, because the percent is just a fraction out of 100. So this tells us that 25 out of 100 people were, like, keep in mind the 100 represents the total, right? In the same way that the 180 represents the total. 25 and n both represent the number of people that sleep with their socks on. And so now we just need to solve for n, and we could just multiply by 180 on both sides and get that n is equal to 180 times 25 over 100. What's that equal to? I could probably do mental math on this. Let's see, 180 is the same as 4 times 45. Yeah, so I could split 180 up as 4 times 45. And so I can combine the 4 and the 25 to make 100. And then I can do that, cancel out the 100 with that 100, and I'm left with n is equal to 45 people. So 45 people sleep with their socks on. All right, let's do the next one. Let's say that 17 people polled sleep with their socks on, and then let's ask how many people were polled. All right, so here we can do a similar thing. You can say 25 out of 100 people sleep with their socks on. And then here we know that 17 people sleep with their socks on. So both 25 and 17 represent the number of people sleeping with their socks on. And we don't know what the total is. So I'll say n is the number of people that were polled. And now we just need to solve for n. So we'll do 25n is equal to 17 times 100. And then we'll divide by 25 on both sides. So n is equal to 17 times 100 over 25. 100 over 25 is equal to 4. So n is 17 times 4, which is equal to 68. All right, so 68 people were polled. All right, next example. Let's suppose that, I don't know why I decided to keep with the socks thing for so long. I have regrets. All right, let's suppose that out of 500 people surveyed in a town, 280 of them sleep with their socks on. What percentage of people surveyed sleep? So now we just want to know, like, what's the percentage? So this one is like probably a little more straightforward than the other one because we don't really have to solve for anything. We can just say, like, we're converting 280 out of 500 to a percentage. And 280 out of 500, if we want to convert this to a percentage, you could do any of the methods that we kind of talked about before, where we could just divide 280 divided by 500, see what our calculator tells us. That's a decimal, convert it to a percentage. Or you can convert this to a fraction out of 100, by, well, you can cancel a factor of 10 from the top and the bottom. And then, well, hey, your denominator is 50, so I can multiply by 2 over 2 to get 56 out of 100, or 56%. So 56% of people sleep with their socks on, according to this survey. All right, percent equation is the other method that we sometimes use. So here, okay. So I don't know if anyone ever actually calls this the percent equation. People like, but basically what it is says like, if P is like your percentage and B is your base. I don't know who calls it the base, but the base, the book uses this terminology. It just represents like the total amount. So this would be like if you're doing a survey where like 20 people like the color blue out of like 100 people surveyed, the 100 people surveyed would be your base. And then P, your percentage, times your base is equal to the amount. So if you say 20% of the 100 people is equal to the amount of people being polled, or the amount of people that like the color blue, or whatever your poll thing is. Okay. Yeah, so this is known as the percent equation. Please don't memorize it, just know how to use it. All right, let's suppose that out of 532 people surveyed in a town, 184 of them floss daily. What percentage of people surveyed floss daily? So here we can just do 100. Let's see. So you could just do 184 out of 532, and then just see what your calculator tells you that is equal to. And so this is like 0.34586, so I'll just say 59. So it's roughly equal to this, which is 34.59%. This is kind of coming from the, I don't know why this like keeps on skipping slides. Yeah, so this is kind of coming from the percent equation. I'll come back to the previous slide, but whatever. So yeah, the percent equation would be saying like, P is your percent times 532 is equal to 184. So percent times 532 is equal to 184. So your percentage is equal to 184 out of 532. And so you don't really need to like do this every time that you're doing this. Like you could just do, this is probably what I would do like 99.9% of the time, but just kind of know that it is sort of implicitly coming from this. Okay, let's see what like you would actually use it for. So let's suppose 32% of people surveyed in the town floss daily, and then we'll do like a similar thing to what we were doing in the like the socks example, where we say 150 people were polled. How many of them would floss daily according to this information? And then we'll do the reverse of where we know how many people floss, and then we want to know how many people were polled. So if 150 people were polled and 32% of them floss, then we can say 32% times 150 is equal to the number of people that floss. So 0.32, so n is equal to, now I'll convert this to a decimal, 0.32 times 150, and then just see what my calculator tells me that this is equal to. So 0.32 times 150 is equal to 48. So 48 people floss daily. All right, now if we say 38 of the people polled floss daily, how many were polled? Here we can say 32% of the number of people polled is equal to 38. So 38 is like your amount. So 32% of like the number of people polled is equal to the amount of people that floss, which is 38. So 0.32 times n is equal to 38. So now I can divide both sides by 0.32, get 38 divided by 0.32, and see what my calculator tells me this is. So 38 divided by 0.32 is equal to 118.75. So n would, this represents like number of people, so it probably makes more sense to say that n is equal to the nearest whole number, so n would be 119 people. Okay. Great. All right, percent increases and decreases is going to be like the last kind of topic. So let's suppose that last year a town's population was 1,100. This year the population is 1,250. By what percentage did the population increase from last year? So there's two main ways of doing this. Way number one that you could think about this would be first figure out what the actual change is, and then figure out like what percent is that of your original population, and we'll do that first. So I'll call this option A. So you figure out the difference, 1,250 minus 1,100, which is equal to 150. That would be like your first step. And then your second step would be, well, your percent increase is equal to just 150 as a fraction out of 1,100, and then just convert this number to a percentage. So this is the same as like 15 over 110, so I'm just going to pop that into a calculator. So 15 over 110, 150 over 1,100 is equal to 0.136363 repeating. And so I'm just going to say that this is 13.63 repeating percent. So this would be your percent increase. Okay, another way that you could do this is just figure out, well, all right, what is 1,250 as a percentage of 1,100? So most of the percentages that we've been doing so far have been percentages that are less than 100. But like, of course, you could say like, oh, I currently have 200% of what I had last year. That would mean that I have double what I have last year. Like you could still do that, and it makes perfect sense. So 1,250 out of 1,100. I'm just going to convert that to a percentage. And 1,250 out of 1,100, my calculator is telling me this is, as a decimal, this is 1.1363 repeating, or 113.63 repeating percent. Okay, so you could do that. And then, well, if this is like what you have now compared to what you had before, well, before you had 100% of what you had, and so now you have 113%. So your total percent has gone up by 13.63 repeating percent. Okay. Sorry, my dog has a squeak toy. I've been trying to get it to not squeak the toy next to the video for forever. We're just gonna roll with it. All right. Suppose that last year the town's population was 1,500, and this year the population increased by 20%. What is the town's population this year? All right. So if the population is going up by 20%, well, first thing that we need to do is figure out what is 20% of 1,500. And that would just be, so you could just do 0.2 times 1,500, or you could realize that 20% as a fraction is just 1/5. And so what is 1/5 of 1,500? Well, 1500 divided by 5 is equal to 300. Okay, so 20% of 1500 is 300, so that means that the population goes up by 300. So if it increases from 1500, then we would go up to 800. All right. Population decrease is very similar. So let's suppose that last year the population was 1250. This year the population is 1100. By what percentage did the population decrease from last year? So this is almost like exactly the same as like this one, same numbers and everything. And this was intentional because I want to highlight that you kind of need to pay attention to like what the base is in these problems. So the base is always going to be like what you like started with previously. So here the population is going down from 1250 to 1100. So I'll split this into like the two methods again. So we first figure out what's 1250 minus 1100. That's again going to be 150. So the population is going down by 150. And then 150, we need to figure out what this is as a percentage of last year's population, which was 1250. And so what is 150 divided by 1250? Calculator is telling me that 150 over 1250 is equal to 0.12 exactly, so 12%. So 150 over 1250 is just 12%. And so this would be a 12% decrease. Notice that we had the same numbers. We went from 1250 down to 1100, and that gave us a 12% decrease. Whereas before, we had 1100 up to 1250. That was not a 12% increase. It was like a 13.63% increase, right? So you might expect, like, well, if we go up from 1100 to 1250, then go down from 1250 to 1100, then those percentages like would be the same, but they're not, because you're considering it like this increase or decrease as a percentage change from either 1100 or of 1250. So 150 as a percentage of 1100 is this. 150 as a percentage of 1250 is this, 12%. Okay, here's the other way that we could do, like, so we could just figure out what is 1100 as a fraction out of 1250. So we're always figuring out what it's a fraction out of like whatever the original population was. And this would be equal to, calculator would tell you that this is equal to 88%. And so if we're at 88%, so before we were at 100%, and then if we go from 100% down to 88%, how much did we go down by? Well, 100 minus 88% is just equal to 12%. And so that would tell us that it's a 12% decrease. All right, last thing. Let's suppose that last year the town's population is 1250. This year the population decreased by 10%. What is the town's population this year? All right, well, first thing that we need to do is just figure out what is 10% of 1250. And that is just going to simply be 125, because you can just do 0.10 times 1250, which just effectively moves the decimal over one place. So it's 125. And then you just do 1250 and then go down by 125. So what's 1250 minus 125? That would be 1125. I think that would be 1125. So yeah, that would be the population this year. All right, that's it. This video maybe went on a little long. Sorry if my dog's toys were too loud in the background. I tried very hard to get in a good take where the dog is not playing with the toy, but she has infinite toys, and I could not hide all of them. I hid some of them. It didn't work. Anyway, yeah, I'll see you in the next one.